So let's go ahead and look at another example of a system specification and try to figure out if it is consistent or not. So in this example right here, let's say that you are working with some sort of system that has multi-threading. So you have multiple threads, multiple concurrent processes that are attempting to access data, and that data might be shared or not. And you have a certain specification, a list of compound expressions that is as follows. The global interpreter lock, and if you've ever worked with multi-threaded applications, you might be familiar with global interpreter locks. And these are things that, or programming paradigms that ensure that your program is thread safe or not. And so I am going to abbreviate global interpreter lock as GIL, global interpreter lock right here. So here we go. We've got ourselves a nice long list. We have got 4 specifications right here that we have to see whether or not they are consistent. So we have the global interpreter lock is active if and only if your program is thread safe. Thread safe, if you're not familiar with that, means that you don't have threads trying to access and change the same shared data at the same time, which could cause many problems in your code. Second specification, the global interpreter lock is active or multiprocessing is not available. The global interpreter lock is not active. The global interpreter lock is active if multiprocessing is not available. So once again, I want to translate these things into propositional logic and then see whether or not they are consistent. So again, I'm going to be looking for these keywords. And so I see an if and only if right here. I see a not right here. I see an or right there. I see a not right here. I see an if. And I see a not right there. So this can help me to try to figure out what my propositional variables should be. So one should definitely be about the global interpreter lock. Another one should be about the program being thread safe. Another one is about multiprocessing being available or not available. Well, there's the global interpreter lock again, and multiprocessing right here shows up once again. So this suggests that we have 3 different logical variables that we could use to translate this specification right here into a logical expression or a list of logical expressions. So let's go ahead and do that. So since the global interpreter lock showed up in a couple of different places, I'm going to make that be the proposition. The global interpreter lock is active. And then I'm going to say, and I use A right here because it'll remind me that it's active. S is my program is thread safe. And lastly, I had multiprocessing. So I'm going to define these as my three propositional variables right here. And let's go ahead and interpret these logical statements right here into propositional logic using these particular variables. So if I were to go and do that, then this very first one right here tells me that I have the following. The global interpreter lock is active if and only if your program is thread safe. Well, that would be active if and only if thread safe. This next one, the global interpreter lock is active or multiprocessing is not available. So I could represent it like this. This next one tells me, well, wait, it tells me the global interpreter lock is not active. So what it's actually telling me is the truth value of that particular propositional variable. So it's telling me that the truth value of this variable right here, A, is false, which is quite handy because then it's going to be easier to interpret these compound expressions here. But let's move on to the very last specification we have here. The global interpreter lock is active if multiprocessing is not available. So remember the many different ways that we can represent implication right here. And so the way that we would represent this is if multiprocessing is not available, then the global interpreter lock is active. So not multiprocessing implies global interpreter lock is active right here. And so what we want to do to figure out if this specification is logically consistent or not is figure out if the conjunctive of this, that, and that compound expression is going to be a contradiction or not. So here, if I were to do that, I'm going to have a bunch of different variables. In particular, I have A, S, and M right here. So I have A, I have S, I have M, and then I have this nice big conjunctive right here. And so I'm going to do a bit of scratch work in the middle again. So once again, I'm going to do some scratch work. And this scratch work is going to be as follows. I'm going to have A if and only if S. I'm going to have A or not M. There we go. So that is all of my scratch work in the middle. And at the very end, I have my big old conjunctive of all of these guys together. There we go. So I have my A if and only if S and A or not M, and not M implies A right here. So I need to go ahead and try to fill out this big old truth table right here. The really handy thing about this particular example is that it's actually given us the value of one of these logical variables right here, and it tells us that A is always false. So we know that no matter what we're talking about, A is always going to be false. And then we just need to figure out what the value of these compound propositions are and their conjunctive, given all possible values of S and M. So I'm going to fill in the very first one right here, and I'm going to leave the rest right here for you to do on the side as scratch work, because otherwise this is going to be long and tedious to watch me fill out this entire truth table. But basically, let's go ahead and fill in this first one. A if and only if S. Well, we remember that this biconjunctive right here, and you might notice that I'm using an alternate expression right here. Some people use this double-headed arrow. Some people use a single-headed arrow right here. It's the same notation. Just like there's a bunch of different ways to do not, there's a bunch of different ways to do implication or by implication. But in any case, this right here, we know only takes on the truth value of true when both of these variables have the same truth value. So we're looking at A and S. So we're looking at A and S. These do not have the same truth value, so they are false. These do not have the same truth value, so they are also false. These do have the same truth value, so they are true. These do have the same truth value, so they are true right here. And you know what? Actually, I can take a shortcut. I can take a shortcut because this right here is conjunctive. And we know that the only time that this thing is going to be true is when every single one of these three underlying statements is true. So if A, if and only if S is false, we know immediately that this is false and this is false right here. And so we actually don't even need to fill in the rest of that part of the truth table right here. So I might be able to do this just by hand. I only need to figure out the rest of these guys right here. So let's go ahead and do that. A or not M. Well, A is false. M is true. So A or not M, that is going to be false or false. That's going to be false. Haha! So once again, I know since that particular part of this compound expression right here is false, this whole big conjunctive is also going to be false. And let's go ahead and do the rest of it. So if I go ahead and do this one, well, I have a false or true. Ah, dang it, that's true, so that doesn't help me over here. Well, what about this very last one? So we have not M, so that's going to be a true, implies false. Hey, true implies false. That's the only time where the implication right there is false. And there we go, I get a false. So I didn't even need to fill in the complete bit of the truth table right here because I used some properties of the conjunctive, knowing that it needs all of these to be true for the entire compound expression to be true. So you will notice right here that everything is false. Everything is false right here. So this thing is a contradiction. And because it's a contradiction, what that means is that this specification right here is not consistent. So given the specification right here, it is not consistent. There is no way that you can find some combination of truth values of A, S, and M that would make this entire list right here be true. And so we have seen a couple of different examples. One example where the specification was consistent because it was not a contradiction. And here we have seen an example where it did lead to a contradiction with a conjunctive. Therefore, it is not consistent. So it can be helpful when designing a very complex piece of software, a piece of code, if you write down all of the specifications that you want to be able to interpret them into logical expressions. And then, if you remember with the previous video with NLTK, you can actually automatically check for yourself whether or not that thing is a contradiction or not. And that can help you decide whether or not your specification is actually going to be consistent. And if it's not consistent, you might have to go back to the drawing board, drop a few features, relax a few conditions, move a few different things around, etc. But it can be very useful for when designing very large, complicated pieces of software or hardware to make sure that there's at least some combination of these variables right here that will make sure that your list of specifications can actually be satisfied. You can actually write code or design hardware that will satisfy all of them.